Kepler's third law of motion. Now let's find the relationship between the period t and the orbital radius r for any orbit. We have our velocity is 2 pi r over t, and we used that in the last topic. And what do we do then? Here's our velocity in a specific orbit. Here is another way to express the velocity, 2 pi r over t. We never like square roots, so we're going to square both sides. And we get gm over r is 4 pi squared r squared over t squared. We do some more moving around of the variables, and we get t squared over r cubed is 4 pi squared over gm. Kepler found that the ratio of t squared over r cubed yields the same result for all the planets. That is, the square of the period of any planet's orbit divided by the cube of its distance from the Sun always yields the same number. That's because this over here is a constant. It is the same for all orbiting objects, where m is the mass of the object being orbited. It is independent of the object that is orbiting it. This expression here is very powerful. If you know the period of a planet's orbit, you can determine its distance from the Sun, or vice versa. Since all planets orbiting the Sun have the same period to distance ratio, this is always true for every planet in our solar system. All objects orbiting a central mass, like the Sun, have the same period to distance ratio. This ratio here is true for all objects orbiting that same object. The value on the right is constant. It only has to do with the mass of the orbited objects, such as the Sun. As long as the orbiting objects are all orbiting the same larger object, for example, the planets in our solar system all orbit the same star, the Sun, we can set the ratios equal to each other and solve for the unknowns.